Good afternoon, and welcome to today's webinar titled Electrical Conduit Systems and Installation Trends for Data Centers, sponsored by Champion Fiberglass. I'm Ellen Parson, Editor-in-Chief of ECNM, and I'll be your host and moderator today. To begin, let me explain how you can participate in today's presentation. First of all, if you have any technical difficulties during today's session, please put your question in the questions window, and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as those can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We will answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the Submit button. Also, please be aware that today's session is being recorded and will be available on the ECNM website within the next week. You'll be notified by email when the archive is available. There will be a certificate of attendance awarded at the end of the webinar. Please note that you must attend for a minimum of 50 minutes, that's 50 minutes, to qualify for this certificate. The certificate will be emailed to you directly within 1 hour of the conclusion of this webinar. Now I'd like to introduce today's speaker, Matt Fredericks, Director of North American Business Development at Champion Fiberglass. Matt brings a decade of industry experience to his role at Champion Fiberglass. He previously worked at Upper Midwest Utility Sales, a manufacturer's representative agency. There he specialized in selling Champion Fiberglass Conduit to electrical contractors and the utility markets. As the Director of North American Business Development, he is responsible for developing high-level relationships within the electrical and utility contractor end-user markets to increase Champion Fiberglass market awareness and sales revenue. He also works with the VP of Sales and Marketing and Champion Fiberglass manufacturers reps to grow and expand the customer base and market share in North America, specifically the United States, East and West Coasts, and Canada. Fredericks has a BA from the University of Minnesota, Morris. Matt, over to you.
Hey, thanks, Ellen. Super excited to be here today. Very, very exciting topic that we're talking about, especially being that data centers and AI are really a growing and bleeding edge topic for electrical contractors and the utilities that serve them alike. So really appreciate everybody taking the time to hear a little bit about Champion Fiberglass, but also just what's happening in the market in general. So just briefly, we will be discussing our product, Fiberglass Conduit, but we'll also be talking about those trends in general as well. So what's actually happening with the market right now is tech and energy sectors are fueling growth due to AI and grid updates. Well, what does that mean? We're seeing things that I never thought we'd even talk about. Things like 3 Mile Island being reopened in conjunction with the Constellation Group to fuel different data centers and AI projects in Pennsylvania. You're talking about microgeneration plants with nuclear, even possible outages of power reduction in areas where electric co-ops have had an abundance of power for years. So power generation is really in this stage of rethinking, or how do we ramp up more generation to service AI and data centers. But we're also building so many data centers and AI facilities that contractors are obviously taking a look at how can we build them faster, better, more sustainably, in a smaller footprint, et cetera, et cetera. We know that confidence in the construction industry is being bolstered by government funding. That, of course, comes from things like the CHIPS Act, the Infrastructure Investment and Jobs Act, many, many other spaces. You can even look at things on the utility side of life in RUS funds, USDA directed funds to places by rural utility cooperatives and rural telephone cooperatives as well, because AI and data centers, obviously, as discussed before, need power, but they also need a heavy amount of communications and fiber cables going to and from them. So what's really happening right now is, according to the slide here, we're seeing that data center demand is forecasted to grow by 10% per year until 2030. I honestly, from what I'm seeing and what I'm hearing from industry peers on the contracting side, engineering side, and the utility side, I think that number is actually quite conservative. You see how fast technology is developing right now. You've got AI being directly integrated into our cell phones, our computers, our tablets, even scarily enough, our cars. I seem to be setting off the AI system in my car quite frequently right now. So it's really embedded itself in every part of our lives. So very interesting, just what will happen over the next 5 to 10 years with AI and how it will, of course, impact the electrical market. So what trends are we seeing specifically, when it comes to electrical construction that may help or hurt, hinder, enhance, just impact the construction in general? Well, if you haven't heard about it yet, you're going to hear about it really consistently, probably from now until the government comes out with the next act. And that is the Build America, Buy America Act, or BABA. So what that is it's a very stringent package of regulations on product material, what percentage of the raw materials can be or should be made in the United States. This is impacting really any type of products that are going into any spaces that receive government funding. And the percentage increases over time, I believe until either 2028 or 2030, where I think it's around 80% of the materials need to be made in the United States, and the raw materials need to be made in the United States. That does pose a problem for certain aspects of products in the electrical industry right now. And for other manufacturers or other types of products, it will be certainly a windfall. But there's definitely going to be a stress, on making sure that products are made in America and the raw materials are sourced in America. So I would say definitely be mindful of that act. It's going to be something that you're going to hear a lot about. Complex buried installation. Well, what do we mean by that? Certainly there are spots in the country where data centers are going to be put up literally in the middle of a cornfield. If you go out west of Des Moines, which is 4 hours south of me, I'm in St. Paul, Minnesota, you can see hundreds, well, maybe not hundreds, tens of data centers. Feels like hundreds because they're so big. Really in the middle of the vastness of the heartland of America. But there are also data centers that are in the middle of downtown areas too. So, how do we make the footprint small enough to meet the demand in urban and suburban areas for this type of data? Well, that's a little bit of what we'll be talking about today. But a lot of what the engineers are dealing with right now is how do we make the footprint smaller? Of course, prefab and pre-assembly is a large portion of that too. If you go to any electrical contractor, large or small right now, there's such a large push to looking at how can they prefab duct banks, risers, really anything in their facilities, truck it out to the site and simply drop it into the trenches or into their building map. BIM modeling is a huge part of that. being able to work with all of the different systems in a building, prefabricate it there so it can fit in with any type of piping or infrastructure that has to go in along with the electrical conduit, because of course data centers do need a lot of ventilation and cooling as well. So there's quite a bit of HVAC in those buildings. Shortage of skilled labor, that's a huge deal. I was just in Hawaii last week. There's, many large jobs going on over there, but there's not enough skilled labor, according to numerous contractors that I spoke with, really to push a lot of those jobs forward. So, trying to work to get people from the mainland over to Hawaii, or looking at products that can save labor. Being that they're on an island, obviously it is harder to find that skilled labor, but that problem isn't specific to just Hawaii. It's all over the United States. You talk to any electrical contractor, and it's really how do we keep and retain our skilled labor, even though, of course, being in the electrical world is a great career opportunity. So what type of conduit is generally used in data center construction? You're looking at really 4 different types. You're looking at GRC, or galvanized rigid conduit. That would be for areas of heavy soil compaction. PVC coated is going to be used in areas of heavy soil compaction as well, but also might be used in areas with corrosive soil. You see a lot of people, especially in the Southwest, having to tape their GRC elbows so they don't rust out with that non-corrosive tape. So they might say, well, we'll use a PVC coated elbow, and that might help mitigate the issue. Schedule 40, Schedule 80, EB duct, that clearly has been a choice for a very long time for large scale commercial jobs for duct banks and underground work. Really, again, everyday use for short runs or underground distribution, both on the power for commercial and industrial applications, but also on the utility side. Where we come in, and fiberglass in general comes in, is depending upon the wall thickness, fiberglass can be used actually in areas of heavy soil compaction. We're highly corrosion resistant and non-metallic, so makes sense that we can be used in corrosive soil, and of course for everyday use for longer runs and underground power. So what type of challenges are people facing that we're hearing out in the field? One, of course, is elbow burn through, and what do people have to do to mitigate that effort? With elbow burn through, that happens when you're pulling a pull rope through a PVC 90. If the tension increases and the heat of that rope increases enough, it will literally saw through the inside edge of that elbow. That's a huge drag if it's direct buried, because generally that rope is coming right through the ground. You can see it quake up, and your cable has been compromised. But it's even worse when it happens in concrete encased applications. Obviously, you're jackhammering up a ton of concrete to replace that elbow. I had a utility that I was talking to at the Lineman's Rodeo a couple weeks back tell me that every time that happens, it's at least $8 to $10 grand for a jack up and a re-pour of that concrete. I would say that's a pretty conservative estimate, because they're talking about perhaps a few elbows in a utility style basement application. You can only imagine what that is for a data center that has hundreds of thousands of elbows if you're burning through quite a bit of them. So it makes it difficult with trying to replace that wire. It slows you down. You have to pull slower, and sometimes pulling slower isn't enough. The weight of the cable and the heat on that rope can be, just enough to saw through it. Cable faulting is, of course, another concern. Nobody wants a cable fault. Obviously, electrical contractors, cable manufacturers, everybody involved does absolutely everything possible to make sure that these incidences don't happen, but they do happen from time to time. So what happens when a cable faults? Well, if a cable faults inside of PVC conduit, it actually melts to the wall of the PVC conduit, which means that it's really not going to be able to move out of the conduit to be able to reconductor the conduit. If it happens in metallic conduit, it's going to weld to that conduit. It's highly inconvenient. So, if that happens, really, what's going to happen? Well, if it's concrete encased, you're jackhammering it up, you're cutting out a section of the conduit where the cable is melted or welded to the inside, you're monkeying around with split duct or whatever, repairs are available. It's a real pain in the neck. It's highly time consuming. It's extremely costly. You've got downtime. It's just not a good deal to have those. So, let's dive in a little bit more. I know I talked about space requirements with complex buried installation, but we want to talk about maybe some aspects of installing other types of conduits that complicates or adds costly effort. PVC, being that it's put into concrete and is a welded together product, you have to use a joining technique like gluing and using that PVC weld. That has the potential to add quite a bit of installation time. You talk to any electrical contractor, utility, you will seldom talk to anybody in the field who hasn't, accidentally kicked over a piece of, a can of PVC weld. So what do? Well, you just made a mess. Your boots are probably stained purple or blue now, and you got to go find a different can. It can be a real pain. Same with turning together conduit as well. That can be quite cumbersome. Heavy conduit is another thing. If you're looking at steel, generally a 10-foot piece of steel is going to weigh roughly 100 pounds. Even PVC Schedule 40, you're looking at weight that's going to be about 2.3 pounds per foot, 3.2 pounds per foot for Schedule 80 as well. So it gets heavy and cumbersome. Lack of manufacturer guidance and support, it might depend upon what manufacturer you're working with. Of course, I believe that every company wants to do right by their customers, but some will offer you more technical support, perhaps field training than others. And then lack of planning and foresight on challenges. A lot of these products or projects are planned out years in advance, but material shortages, supply chain issues, variances, permitting, all of these things can really cause a herky-jerky start, and it might be difficult to get the materials that you need in time, or you're subbing out for a different material to keep the project on track. It's just kind of the way of the world with how these projects work, because they're so large and require so much permitting and variances. So materials and installation cost. Going back to supply shortages, we saw PVC skyrocket in price back in 2020 and 2021, going up, 800 to 900%. Steel, of course, can be volatile depending upon what's happening. We've got tariffs that might be coming in. There's just so many different variables that happen with different type of commodities. We talked about the longer installation and larger costs due to joining techniques and weight. We're really going to unpack that a little bit later in this presentation when we talk about NECA manual of labor units, which I find very helpful, really just to compare the different conduit types and how that all plays out. And then, there are folks that still aren't prefabbing their duct banks and pre-assembling their risers and stand-ups. I'm seeing the contractors that are doing that prefab ahead of time, they're really the ones that are getting ahead. Being able to do that in a prefab application, especially for duct banks, being able to lift 40 feet of conduit, setting it on a flatbed and then craning it off, putting it on the side of a duct bank. That's huge if you can do that and eliminate time in the trench. Not only is it safer and cheaper, but just circling back to safety, that time in the trench, if you can reduce that, really reduces chances for injury. So we'll talk about a couple data center projects that we've done at Champion that I think are pretty interesting and enlightening. And I really think that they speak to the value of our product and what fiberglass can offer that's really different than the metallic or plastic conduit types that folks may be used to using. So the first one that we'll talk about is a data center that we did in the Midwest. This was really actually our first, we call in our office, a PVC conversion. So 3 to 4 years ago, we were looking at PVC going up, 800 to 900%, like I say, and fiberglass was in a very unique position. We were finally less expensive than PVC, really for the first time since fiberglass it existed in the conduit space. What that illuminated, though, from a price standpoint, was the labor savings. We'll talk about that in the next slide, but I just want to tee you up because it's extremely exciting. This is really what opened our eyes to the opportunities that we could offer to our contractors and the engineers. So what was this contractor and end user facing? Well, we talked about PVC. Not only did the price go up, but you really couldn't get it. Lead times were horrific, and you were seeing people beg and plead for material everywhere, and that's when a lot of people were coming and knocking at our door. So the contractor, after we spoke with them and showed them, what was possible with our labor savings, our weight, many different aspects of this job, they ended up selecting fiberglass, not only for the elbows, which have really been the rule of thumb for data centers for a long time. That's just generally accepted practice because we cost significantly less than metallic elbows. We don't rust out like metallic elbows. You don't have to tape them. We weigh a tenth of the weight, and we don't burn through like PVC. But they also used our straight sections because we have a very low coefficient of friction, significantly lower than PVC and steel, which is hugely attractive for cable pulling, a reduction of chances for fault. So that's why they picked us. But what did they find? Well, it scared us and made us very excited at the same time. They told us that their rule of thumb is they could install about 3 miles of conduit in about 5 working days or in a week, and they were using our 4-inch conduit. Well, about a little over 15,000 feet is what we can fit on a flatbed of our 4-inch conduit. So we said, we'll send you a truck a week, no problem, keep you fed. And that'll meet the pace because we figured at this point, like, hey, they've never used it before. We didn't really know how much faster it would be. Well, we sent it up to the contractor. I believe it was on a Monday. I think it arrived there. I think it was like Monday around midday, and the contractor ended up calling us that following Tuesday afternoon, and they said, we're out of conduit. And that's when we really had our aha moment, and we really started to realize that we were going to get an avalanche of business because we knew right then that if that contractor installed our product literally 5 times faster than PVC, that, not only were they saving a ton on the purchase price, but the labor is what really can never be taken away. Somebody is always going to have to put together this conduit, no matter where the price is with commodities. Being that labor can be upwards of $170 an hour in places like California, if we can reduce labor, in this instance by 80%, we're saving contractors a pile of money. So in this slide, we're saying it took half the time PVC. Well, if their rule of thumb was 3 miles in 5 working days and they installed it in 1, it's actually close to 80%. But we'll talk a little bit more about that in another slide. But I'm specifically speaking to the straight lengths there. The aggregate total is shown a little bit later. So why did this all work out so well? Well, we really worked well with the contractor to make them fed. We made sure that it was an effective partnership with them and made sure that the delivery was, consistent. They weren't ever waiting for anything. So another project that we did, which I believe is in a case study on our website, was in Data Center Alley. This is kind of the colloquial name for that giant area right outside of Washington, D.C. If you are or ever get the chance to go to DC and go out west of DC, that whole area is just filled with data centers. It's crazy how many data centers there are. So this was another instance where, PVC, they're having issues acquiring it, supply chain issues. It required 25 miles conduit on a tight deadline. So fiberglass was, again, selected for the same reasons that the Midwest data center contractor selected us. So what happened with them? Well, what they really told us is 2 things. They were able to prefab our conduit much easier because our product is 1/3 of the weight of Schedule 40 PVC. We also have a glueless system that allowed them to put it together without having to use any adhesive that's concrete tight and watertight. So the weight was easier to put it together, but also imagine craning those duct banks in. If you're putting together conduit that's 1/3 of the weight of what you're normally using, it's a lot easier to maneuver. So those 2 items, they said, really helped them achieve vast cost savings. So the labor that they saved on the job was 60%, which is massive. And they had a 63% increase in productivity over PVC. We really couldn't have been happier with the results that they shared with us. And it just reconfirmed, what we had been hearing from prior customers as well. So the beautiful thing is these 2 customers specifically have been repeat customers since then. We really know and firmly believe that we're providing a product and service to these ECs that will help them be competitive in the marketplace. So why use fiberglass? And we'll talk in general about fiberglass, not just Champion. We talked about no burn through elbows. That's the low-hanging fruit in this product line by far. Easy to field handle. If a piece of our 4-inch, or rather a length that's 20 feet long, only weighs 14 pounds, PVC Schedule 40 at 4-inch that's 20 feet long weighs 48 pounds. So you can carry 80 feet of our fiberglass and it only weighs 6 pounds more than a piece of, or rather a length of 4-inch Schedule 40. So wrap your mind around that and imagine how productive you can be. Being that it's lighter, it reduces the chance of injury. That comes from perhaps either elbows or conduit. God forbid they fall or roll on you. It's a very different situation having a very light piece of fiberglass come on top of you than a piece of PVC or, of course, a steel elbow. That's the difference between, somebody being very irritated with their coworker and, obviously somebody being very severely injured or potentially dying, which we do not want happening. Low coefficient of friction we covered before. Worst case scenario with fiberglass, you're using a PVC jacketed cable. Our coefficient of friction with the PVC jacketed cable on fiberglass conduit is 0.38. It's 0.55 in the steel with PVC jacketed cable, and it's 0.90 with PVC. So you're seeing almost a 70% reduction, or 2/3 reduction in friction by using a fiberglass conduit over a PVC one, and even quite a bit with steel, of course. We have a high dielectric strength. That's, of course, very nice when it comes to insulation. We aren't conductive because we don't have any metal in us. Couple other things that are unique to what we do. We offer a lot of project guidance. We offer on-site training, custom solutions. Our owner and leadership team have invested heavily in a state-of-the-art machine shop, which allows us to provide those custom solutions that our customers crave. And then, of course, labor and material savings. That's the beauty of this product, is you don't have to give up anything to use fiberglass. You actually get all of these other features and benefits, and you get to save a ton of time and money. That's huge. When everything else is going up in cost, you're looking at a product that's quite price stable, and it's got a much lower installation cost and time to install. So why is that? Is this all in my imagination? Well, no. Why do we know this beyond just contractor feedback? We actually, can reflect on this in the NECA manual of labor units. Some of you listening might be NECA members yourself. You can go in that manual right now. And what we did is we actually compiled all of the conduit types in this chart, rather than having to look through every page to see, what is the true time to install our type of conduit versus everybody else's. A couple things to note. This metric is, from what we know, is based off of 100 feet of conduit being installed at chest height. So this isn't below grade installation, which most people would say would take slightly less time. But if you look at fiberglass, we're less time to install at any size of conduit comparable to stainless steel, galvanized rigid, and PVC coated. Even if you look at Schedule 40, we were astounded. Albeit 3/4 and 1 inch were more time to install, were equal to or less than the time to install by 10-foot sticks from inch to corner and above. And we know that you can reduce labor units by 10% for 20-foot conduit lengths. Well, most people install fiberglass in 20-foot lengths because it's so lightweight. So you can reduce that number, multiply it by 0.90, and that factor is going to go down even more. Similarly, it follows suit for elbows. More importantly, too, I will mention, really the true value of using a fiberglass elbow and labor savings is seen when you're using long radius sweeps. And you can see when you're looking at GRC Schedule 40, Schedule 80, and PVC coated, you actually add 20% to that labor when you're using a long sweep elbow. For fiberglass, that isn't the case because of our weight. I can tell you there's a beautiful slide in our Lunch and Learn. If you'd ever like to see it, certainly hit me up after the presentation, of an individual in our factory holding an 8-inch by 90-degree by 96-inch radius elbow off the factory floor, by the way. That elbow weighs 32 pounds. If it was steel, it would weigh over 400 pounds. If it was PVC, you're looking at 100 pounds at least just for Schedule 40. So if you think about it, an elbow of that size, which is absolutely giant, those long radius sweeps are really where that cost savings can be gleaned. So I would encourage you guys to talk to your contractor peers, engineer peers about where you can integrate this innovative product into your projects. Feel free, of course, to reach out to us at Champion. We love being partners with our contractors. We're very big on making sure that we have long-term partnerships with our contractors and filling in those needs where, you might need something that's custom or a little bit more off the wall. So with that, I'm going to end my presentation portion of the webinar, and I'd really like to open up to the audience for any questions that you might have. Very curious to see what people are interested in. So.
Thank you so much, Matt. That was a great presentation. Let's see what kind of questions we have. It looks like we have several. We still have time to do that, though, so if you haven't already submitted a question and you'd like to do so, please go ahead and submit that. Type your question into the question window on the side of your screen and then hit the submit button. So let's see what we have. Let's see. First of all, this is more of a general one. Could you speak to, someone's asking, can you speak to how cable repairs are made with each of the different conduit types? That's a good one.
For sure. Yeah. So, you know, it certainly depends upon the conduit type. You're going to, have to use split duct for most of them. Steel, it's going to be hard, especially with an occupied cable. PVC, it might be a little bit easier to cut around it, even if it's allowable. There's certainly PVC split duct that you can use to put it together or put together around it. That's got an integrated groove. It clicks together with some split clamps. You could use tie wraps, things like that. So of course going to be up to the AHJ and the project owner as to what might be allowed. With fiberglass, you can use things like split duct. We also have a water-activated repair tape that's actually as strong or stronger than the glass substrate. It's very easy to use. It comes in, I guess it would be like a Tupperware-style container with rubber gloves. You simply pour a bottle of water over it. It looks like an ace bandage. You put a piece or two of split duct over the conduit, and then you would simply wrap that conduit with the repair tape, and it hardens up just like a cast. It's extremely robust. We have a lot of contractors and utilities that are highly interested in that product. So that's a fabulous question. So.
Yeah, definitely. Thank you for that overview.
I do want to answer a couple that I'm seeing in here. Sorry, I saw one pop up that I wanted to answer specifically. Is that okay, Ellen?
Sure. Yeah, definitely.
Okay, so I see that a gentleman asked here, he asked, did you say 8 sticks are only 6 pounds more than a single piece of Schedule 40? It's 4 sticks of our 20 foot long 4-inch conduit are only 6 pounds more than a 20 foot long piece of Schedule 40. So wanted to be clear with that. And then he asked, are they able to be used with tuggers? Absolutely. We have people who pull cable through our conduit all the time, whether it be with electric tuggers or even with diesel-powered tuggers. I used to represent a company that makes bull wheel-style tuggers up here in the upper Midwest. We'd sell them to utilities all the time, and they loved using our conduit to pull through the straight lengths and especially at the elbows because they are very, very, have a very low coefficient of friction, easy to pull through. What's the strength of the connections when using the cable pulling equipment? Well, it depends upon what type of conduit you're using. There's many different joint styles with fiberglass. There's really 4, so it would depend. It can be anywhere from 2,000 pounds of pull-out strength upwards of 10 to 11,000 pounds, which would actually exceed the strength of the glass substrate. So it's extremely strong, and that's sheer pull-out force if you were pulling on either side of the conduit. So another one that I wanted to answer too is somebody asked about the average turnaround time in the ordering process for standard sizes, 2 through 4 inch. This person is asking, like, say 1,000 feet. Well, we're the largest manufacturer of fiberglass conduit in North America. We can turn out thousands of feet of conduit a day. Our lead times right now are running anywhere from 2 to 3 weeks. But we have distributors that stock our conduit as well. So, depending upon how quickly you need something, you can certainly discuss that with us. And if you needed it faster, or if it's an ongoing job, we can certainly discuss how to expedite that, get that out of the factory faster. But generally, our lead times are quite reasonable. Another great question. Do you provide training and certification for installing contractors? Absolutely. That's something that hats off to our owner and our founder, Joran. He has made a huge commitment to making sure that contractors feel comfortable, get appropriate on-site training with our conduit. It's not that it's difficult to put together at all, but it's different. So we actually will fly out to job sites quite often, do on-site training. We send samples ahead of time where people can learn how to cut it. And oh, by the way, you can field bend this too. And we will train you guys on how to field bend it, cut it, glue it, put it together. If you're using our glueless system, our gasketed system, we'll show you you can literally hit together conduit with a wood block and a 5-pound hammer. So anything like that we do. We have people come to our facility all the time in Spring, Texas as well. So certifications, no problem. On-site training, no problem. We do retrains, and beautiful thing now too with all of these data centers, AI and whatnot, we've got cell phones with cameras on it. I've got contractors that if they're in a trench, they know that they can call me on my cell phone at any time of the day or night, point their phone at something that they have a question about. We can get it answered, within 30 seconds. Another really good question. Is your product the same dimensionally as Schedule 40 PVC? Yes, with a caveat. Our product is iron pipe size for what most contractors are using. That means it's going to have the same OD as PVC. Beauty of that is if you have to connect in between dissimilar materials, those connections will work with conduit types that are iron pipe size. The really nice thing about fiberglass, though, or what's in the secret sauce that a lot of engineers and contractors like, though, is that our ID is actually larger than PVC and other iron pipe size conduits because our wall thickness doesn't have to be, less. So what does that mean? Well, you get better cable fill rates. It's easier to pull through. There's so many benefits to having a bigger ID, but fill rates and being easier to pull through would be the two main ones. So, being that it's dimensionally the same on the OD makes it a lot easier, to connect with dissimilar materials, but it's also easier for those cable pullers. Somebody asked, why is PVC not good for a long run? Well, how I would answer that is, it's not as optimal as fiberglass. It isn't that it's good, it's just going to be harder. If you think about the fact that our coefficient of friction is a third of what PVC is, if you were pulling straight run to straight run, and depending upon, of course, what the cable manufacturer specifies as allowable tension, everything like that, you could potentially pull 3 times further than PVC at the equivalent pulling tension than you would, in fiberglass than you would in PVC. We've actually had contractors and utilities come back to us and say, hey, our engineer was able to use their pulling software of choice and actually eliminate every 2 of 3 pulling vaults because, they can pull 3 times further in fiberglass. They were able to quantify that with the engineering data that we put out. So imagine, using an awesome tugger that's out on the market with a slick rope and a really good wire in our conduit, good cable pulling lube, and then using fiberglass. Imagine how many bolts you can save in a system, how much time. how much less stress is on a cable. If you use all those proper things together, all of that will definitely, in my opinion, reduce the total cost of ownership. Of course, we want to have a low installation cost, but a lot of the infrastructure that we're building right now, it's mission critical. It's utility. It's data centers. These things need to be and exist in our sphere for a long time. So it's a very attractive thing that you can propose to your end user when you're talking to them about why they should use fiberglass over something like PVC. So I really like this question that I just saw. These questions are absolutely fantastic, by the way. Thank you, everybody, for asking them. This is a fabulous group. Somebody just asked, please address durability for exposed runs, especially in challenging industrial environments. Well, this is a super good question. The nice thing about fiberglass, similar to PVC, but fiberglass has some distinct features in this regard, is we have different wall thicknesses. So like Schedule 40, they have their companion, which is Schedule 80 for areas subject to physical damage. Well, fiberglass in the NEC code is actually has a wall thickness that would be a companion for that. We're under RTRC, or Reinforced Thermosetting Resin Conduit, under Article 355. So if you pull open your code book right now, you're going to see that our extra heavy wall is allowable in areas subject to physical damage. A lot of times when we're in an industrial environment, especially in mines, we're used in a lot of mines for this reason, people are using that X-wall conduit. Is it any more corrosion resistant? Well, you kind of look at it and you'd say, well, there might be more material on it, but naturally fiberglass is highly, highly corrosion resistant. Really what this wall thickness helps you achieve would be that impact resistance and compression resistance. X-wall is 1/4 of an inch thick. It's often called out in old engineering specifications as bulletproof conduit. It's extremely robust. I've had colleagues that have seen coal haulers drive over it. I mean, it's crazy, crazy robust. So our conduit, being that we have 4 different wall thicknesses, it really comes down to like a pick the right hammer situation. That's where you engage us and engage your code book. And then you can look and we can help you determine like, hey, do I need X-wall here? Do I need medium wall, heavy wall, standard wall? Most of the time it's just standard wall or X-wall. But we can certainly help you navigate through those conduit choices, as you and I and everybody else sees fit. So love this question. How is RTRC connected? Love using that code book name. There's 4 different ways. Really, I'm going to talk about 2 though. What I always say is above grade, you're going to be using adhesive. It's a 2-part epoxy. Don't get afraid when you hear that, because a lot of people, much like myself, when I started using this product, when I heard that, I thought like, oh, this is going to be 2 cans. It's going to be gloppy. I'm going to have to mix stuff. No, it literally comes out of a 2-part caulking gun, and it's in a single caulking tube. It's crazy. There's 2 chambers, but it's in a single caulking tube, and it's mixed in a mixing tip. So literally all you do is apply it to the male end. You twist the conduit while you're putting it on maybe 1/4 or 1/2 turn so it evenly spreads. And once it's set up, that adhesion will be as strong as glass substrate. Now, the real secret sauce of absolutely everything, and it's not so secret because you can see it in our catalog, on our website, and on our YouTube page, is we have what's called a gasketed interference joint, okay? So this combines the interference joint, which is a system that we have that's got CNC'd rings and molded rings, on the female end, CNC'd rings on the outside of the male end. You literally hit it together with a wood block and a 5-pound hammer, and it's got 1,000 pounds pull-out strength, and it's for concrete tight applications. But we take it one step further. We have a gasket interference joint. We add a gasket on the inside of the female end of the conduit. When you put that together, that's 2,000 pounds of pull-out strength, and it's concrete tight and watertight. We can put that on nearly any adapter that we have, any elbow that we have, so you can literally put together an entire underground job and conceivably not have to use a single drop of glue. That is a game changer. You ask any contractor that's using it, that is what is saving them a pile of money and time. It's also very simplistic. You talk about the ability to perhaps de-skill some labor, have apprentices or helpers help you out putting together things prefab or in the field. As long as somebody can hit a wood block with a hammer, they can put that conduit together. So, above grade, use glue. Below grade, you don't have to use glue. I did answer the one that was installed where subject to physical damage. I am going to answer maybe one or two more here. One that I will answer is, do we have any experience installing fiberglass conduit in an overhead rack outdoors? Yes. And I think we actually have pictures of that on our website. There's a couple instances. We've done it on strut that's been inverted, where the conduit is literally resting on outdoor racks. We make bridge hangers. Those are meant to install conduit below bridge decks, which would be the other instance that I'm thinking of. But we do a lot of exposed conduit runs, even in really quite challenging environments, outdoors. Fiberglass has a temperature range that is actually larger or wider than PVC by 100 degrees on either side. So PVC is, positive 40 to about positive 150 for temperature for Fahrenheit. Fiberglass is allowed to go down to negative 60 up to positive 250. So you can use this in areas that get quite hot and actually very cold as well. So it's a great option to be outdoors, whether it be wet, salty, hot, cold, humid, anything like that. It really can be used almost anywhere. So another good question, and I get this one quite frequently. Any suggestion on the large current duct banks thermal management when using fiberglass conduits versus PVC conduits versus rigid steel conduits? Okay, so our coefficient or rate of heat dissipation is significantly better than PVC. I want to say it's roughly 25 or 30%. It is on our website in the back of our catalog. There are numerous software programs now that do include us in their modeling, and spacing for duct banks and the need to derate cable, things like that, happens far less frequently in fiberglass. That's one of the things that engineers and contractors consistently relay to us that they really like about fiberglass is far less of a need to derate the conduit when you're using fiberglass versus other conduit types. So let's see. Another interesting one. Is it my understanding that fiberglass conduit is somewhat porous? Are there concerns with moisture entering the conduit? Okay, well, it's interesting that you say that. We make our conduit in a single circuit filament winding process. Not all fiberglass conduit is made the same. I will just leave it at that. We make ours in single circuit filament winding. What does that mean? When we wind our conduit, we're going all the way down a mandrel with several of these pieces of fiberglass strand or rovings that are completely covering the conduit the entire way. And once it reaches the end of the mandrel, it's going all the way back in the opposite direction. So we're making multiple passes over the conduit. Now, does our conduit hold a ton of pressure? No, it's not like PVC. or rather HDPE, which you can blow fiber through, albeit we're used to protect HDPE a lot of the times. People are pulling multiple, 1.25 inch, 3/4 inch HDPE conduits through a larger casing, let's say for something like an elevated trainway. That's a common use for fiberglass because we offer excellent mechanical protection. We're very easy to pull those conduits through. But as the wall thickness increases, there's of course far less of a propensity for it to be porous. But it's really not, I wouldn't call it porous because we have so many layers of material that are highly resin and hardener rich. Excuse me. Available for hazardous locations. Okay, so that when you're skipping back to talking about X-Wall. So X-Wall is Class 1 Division 2 rated. It is not Class 1 Div 1 rated. We do offer an adapter where you can transition into a PVC coated adapter or any other type of adapter because we do not have a seal off. So you could use somebody else's seal off, to make your connection and make your 5 feet into your Division 1 space. But that X-Wall is allowed in Class 1 Div 2 and the divisions below it as well. So as far as hazardous, we can be used in that, of course. And then I think we'll end with this one. Does Champion suggest any specific PPE when handling their conduit? Well, really, what we suggest is when it comes down to things like cutting. That's when the PPE, beyond like normal job site PPE comes in. When we cut, it's going to create dust. So what you're going to want to use is, everybody has one now, but 4 years ago when we suggest this, it was far less common. Use something like an N95. Wear that mask to prevent the dust from being respired. Our product is low smoke, zero halogens. There are no toxic halogens in it, unlike, of course, PVC. What you're really trying to protect yourself is from that dust going into your lungs. We always recommend using things like eye protection, using gloves, and then using long sleeves when you're cutting too, just to prevent yourself from getting that dust on your skin and becoming overly itchy. But important to note, when you're using just regular cured fiberglass and you're not cutting it, it's resin rich, it's not chop strand, it's all in nice glass rovings that look kind of like either really fancy baling twine or very large dental floss. It's not going to flake off and get in your skin or make you itchy. Really, that would only occur if you're doing a significant amount of cutting. But the PPE is nothing really out of the ordinary that you guys wouldn't already have on a job site. So with that, I think our time is up. I'm so grateful for the fabulous questions that everybody had today. Super appreciative of EC&M for this opportunity. Ellen, thank you so much for inviting me. And
yes,
we wish
thank
you all a fabulous time. I'll hand it back to you, Ellen.
That was such a great question and answer session, Matt, and that was a fabulous presentation. Obviously, with so many questions, we like to see that, such an interactive, active question and answer session. So awesome there. And so I guess that's going to wrap things up for today. On behalf of EC&M, I'd like to thank Champion Fiberglass for sponsoring today's event, and of course, to all of you for joining. Thank you, and have a great rest of your day.